Welcome my dear friends. Here in Rolle's theorem, the definition goes like this, that if a function f is there, okay, say I'll show it with the help of a graph. This is y-axis and this is, say, x-axis. Okay, and now say we are having a function f, or a real valued function f, which is continuous in the closed interval a to b. That means if this is a point A and if this is a point B, then we know it is continuous, that is, there is no break here. So let this be point A and let this be point B. So the function, real valued function y equal to f of x is continuous in the closed interval a to b, and at the same time if it is differentiable in the open interval a to b. So the meaning of differentiable is that the curve should be smooth like this. There should not be any sharp turnings as zigzag fashion like this, because the function is differentiable means that there should be a unique tangent at a single point, say this green point. Okay, so I can easily draw a tangent at this point and it will be a unique tangent. That means the curve is differentiable. But if I consider the same, that I want to draw a tangent at this point, then to the neighborhood of this, that is to the left of this point, say the name of the point is capital P, say, then okay, to the left of this thing, okay, we get a tangent which is represented by, say, this line, and to the right it is something else. Okay, it cannot be same point, say this is this line. Okay, or in other words, if I have a graph of y equal to mod x, which is represented by a V shape in a way, that is y equal to x and y equal to minus x. So we know that this curve y equal to mod x, which is same as this line, represents y equal to plus x and this line represents y equal to minus x. So if I want to confirm whether at origin this function is differentiable or not, okay, directly by seeing this curve I can tell that it is not differentiable, because we are having a sharp turn at O. Or in other words, if I differentiate this thing, or if I try to draw a tangent to the left side of this O point, then it will be this thing, that is its slope will be -1, okay, as seen from this. And if I try to take any point to the right of origin, suppose this is the point, then the slope becomes +1. So whenever left hand derivative is not equal to right hand derivative, we say that the function is not differentiable. So in simple words, the curve should be smooth like this. So Rolle's says that if any function is continuous in the closed interval AB and differentiable in the open interval AB, okay, because at a single point there cannot be two tangents, okay, that's why we have used the word open interval, that is excluding A and B, then there exists a point, always there exists a point C belonging to A to B such that differentiation at that point is equal to 0. Okay, that is the third condition, including that is if f of A is equal to f of B now, then okay, one more condition is there, f of A should be equal to f of B. That is three conditions if then. Okay, so the very first condition is it should be continuous, second it should be differentiable, third Rolls says if f of A is equal to f of B, that is both the y's, both these green lengths should be same, then Rolls theorem says that definitely there exists at least one point C belonging to A to B such that differentiation at that point is 0. Or in other words, we get a point C such that from that point we get a point on the curve, definitely this is that point, and tangent at this point is definitely parallel to x-axis. Okay, parallel to x-axis, like this it has to be. Okay, the same thing we can try another curve, okay, for our understanding sake. Okay, why they have used the word at least. Say this is y-axis, I'll take red color. If this is y-axis, this is x-axis, and this is the curve, but I should remember that this height FA should be equal to this height FB, then only it's okay. Okay, so A and B. So the curve is continuous, the curve is differentiable because there are no sharp edges, and also the green lengths are same. Okay, these lengths are same. Then there exists at least one point. In this case we can see that there are existing 1 point, 2 point, 3 point, 4 point, and 5 points. All these 5 points, if I draw tangent, then its slope will be 0, we know. 1, 2, because we know that slope of a horizontal line is 0. So in a way, for understanding sake, I am telling this thing. Thank you, my dear friend.